Welcome to your second lesson in this unit. Last lesson, we had a greater understanding of scientific notation and how it works. Now we're going to use that knowledge to compare numbers in scientific notation. Below, I have 3 planets and their distance from the sun in scientific notation. Our instructions are to label them from smallest to greatest. Let's take a second to examine these forms in scientific notation. The Earth's distance from the sun, Mars' distance from the sun, and Venus' distance from the sun. A common misunderstanding is to look at the beginning coefficient. When we look at the beginning coefficient, it appears that Mars is the smallest number. But let's take a minute and write all of these scientific notation in standard form. When we convert these measurements into standard form, we see that Mars is in fact the greatest distance. The difference lies in their exponents. Both Earth and Venus have an exponent of 7, and Mars has an exponent of 8. Let's talk about what we know about those exponents. 10 to the 7th power is equivalent to 10 multiplied by itself 7 times, which is 10 million. 10 to the 8th power is equivalent to 10 multiplied by itself 8 times, which is 100 million. We see that in these problems, Mars's coefficient is being multiplied by a greater number, thus making a greater distance. So the one furthest from the sun is Mars. So let's make some rules that we can follow. When comparing numbers in scientific notation, the first thing that we do is compare the exponents. I recorded our steps here. Also note, these rules are for when exponents are positive. All of these exponents are a positive value. So that means when the exponent is greater, that means the solution will be greater, which is true. This exponent of 8 makes Mars' distance greater. Now, how will we compare Venus with Earth when they have similar exponents? Our second step will be to compare their coefficients. When we compare these coefficients, 9 and 3/10 and 6 and 72/100, the greatest coefficient is Earth, 9 and 3/100. So we can add to our rule, the greater the coefficient, the greater the solution. So we can begin to put these in order. Venus is the smallest distance from the sun, then Earth, and Venus has the greatest distance, so it is further. Let's check our answer in space. Now, while we're in outer space, we can examine the order of all the planets. On the far left, not in the screen, is the sun. So we are correct that Venus was the shortest distance, Earth was the next shortest, and then Mars. And there's all the cute other little planets. Let's talk about what it would look like when our exponents are negative. For our next example, we're going to be comparing the amount of gravity between Pluto and Mars compared to Earth. We're going to discover which one has a greater amount of gravity. Here's their gravity written in scientific notation. We know when we're comparing numbers in scientific notation, there are 2 steps we have to follow. The first step is to compare the exponents. We learned that the greater exponent means the greater solution. So let's compare our exponents, -2 and -1. Which is the greater? To double check, what I'm going to do is draw a number line for myself. On a number line, here is number 0, here is -1, here is -2, and here's our positive realm, like 1. Which number is greater, -1 or -2? Correct. -1 is greater because it is more to the right. Because of this, we can conclude that Mars has a greater amount of gravity compared to Pluto. How do we know? Because in our first step, we compared the exponents and -1 is greater than -2. Let's try a couple different examples. Your check for understanding today is these two problems. I would like you to tell me which one of these two and which one of these two is greater. I also want you to explain why you know which one is greater in a sentence. A good way to explain our answer would be, I know blank is greater because. So answer these two questions on a separate piece of paper. Don't forget to write an explanation sentence. When you turn this into your teacher, your math community will get your work for today. Thank you.